a way of showing you something that we looked at before. Sine of an angle is equal to sine 180 minus that angle. These two, it's like they're on a straight line.
Yeah.
And so it's like 180 minus. And then this one, same thing. This sine graph is symmetrical, about 90 from 0 to 180. And so if this is theta, then 180 minus theta would also give you the same sine theta.
Yeah.
Let's see this. We've got two possible values for this thing.
Okay.
So my sketch may not be perfect. ABC is 44.
Okay, so we use the sine rule for this.
Yeah.
Okay, so it's 3 over sine 44 equals 4 over sine x.
Yep.
And then can we put that into the calculator?
Give it a go. Pick lucky 7.
Yeah.
Don't pick your crazy huge numbers. I'm gonna pick your crazy number.
I got 67.9.
Oh, I got the same thing. Okay, so 67.9. Two possible values for this angle.
Would there be a negative angle?
Sine theta is equal to sine 180 minus theta.
Okay. So you do 180. Would you do 180 the minus the angle?
Yep.
So 180 minus 67.
Yep.
67.9, which is 112.1 degrees.
Let's just say that's 112. All right, 0.1. Let's see. And so my sketch, you can have it a different way in your sketch. There's two possible ways you can do it. So we found the angle opposite 4.
Yep.
The angle opposite 4. So we found this one, which was the acute angle.
Yeah.
But that's if the triangle has a side length of 3. AC is 3. But another possible way of doing it is this weird type. AC is 3. Control button isn't working. And so this angle here was the bigger one. This angle here was the smaller one. Add them up, you get 180. Oh grand, oh grand, oh grand. Okay. Alright, let's give this a go.
Okay. Okay. Could you use the sine rule to work out the bottom, like The triangle on the left at the bottom.
Yeah.
Okay. So it'd be 60 over sine 40. Is that right?
Yep.
Equals 80 over sine x.
Mm-hmm.
No, wait, yeah. Yeah. I got 58 point. Well, it's 58.9869. 69.
Okay. So what angle did we just find?
We found the angle opposite 80 meters.
There are two angles opposite 80.
That one. Wait, oh no. No, it's the one all the way in the bottom right.
That's right.
So now we know that angle. Are we able to work out the other angle? Like doing 180 minus... Wait, we don't know that angle, do we? No, we don't.
180 minus would give us the other angle, but we're trying to find this angle x. How can we do that?
So we have 40 degrees, we have 58.9869, and we have 80 meters. Could you work out the side of the triangle all the way on the right using sine rule?
Let's say you're onto something, but it's much easier than that. This is the wrecking ball at two different positions, if I'm correct, and so these two are it's the same side.
So it's isosceles triangle.
Yep.
Okay. Yep. So that means the other angle is 58.9869.
Yeah. I'm just gonna write 60.
And then you multiply 58.9869 by 2.
Mm-hmm.
I just multiplied the answer, so I got 117.9739. And then you do 180 minus answer, which gives you 62.02 degrees.
So let's say x equals 62.0 degrees, and I shouldn't have called this x. I don't know, y or something. There you go. 62 degrees, great. One modeling assumption we made.
What does that mean?
Like for mechanics it'd be like there's no friction, like no frictional force or something like that. I don't know.
You can say that there was like if it was a wrecking ball that was moving, would air resistance be taken into account or no?
So no air resistance would be another thing for I don't know what they're talking about. The assumption is that the ball swings symmetrically.
Okay.
All right, fair enough. Yeah. All right. And so what this was kind of testing was that you wouldn't say this obtuse angle is 58.9. You would say that this one over here is.
Yeah.
That's what the big test there was. All right. Unless you have any questions.
Nope.
Area of a triangle.
Okay.
Usually it's a half times base times height, but we don't have the height.
Okay.
Do you already know how you do this?
Would you use cosine rule?
You need a new thing. Do I have a triangle? So this triangle. Why did they? I have a better one, but I won't go looking for it.
Oh, you split it in two triangles?
Yeah. So you have a triangle. This is the height. B is the base. This is the angle C. This is the side A, let's say. But we don't know what the base is. So area of a triangle is a half times base times height.
Yeah.
I forget how I did this. Yes. What is sine C in terms of H and A?
What do you mean by like what in terms of sine C, H, and
A? So like sine C, we don't have any number, so it won't be like sine C equals 60 or anything, or sine C equals 0.5. It'll be letters.
Okay, so it'd be sine C equals, because sine C is opposite the height, so it'd be H.
Yeah, opposite over hypotenuse, and so height over
Opposite. Oh, 90 degrees.
No. Opposite over hypotenuse. Which side is the hypotenuse? In the left triangle.
So it'd be the adjacent and the height.
Yeah. So sine of an angle is opposite over hypotenuse.
Yeah.
Which side is opposite the angle C?
The height.
Which side is the hypotenuse in the left triangle?
Oh, the top.
What's it called?
A.
Yep. Okay. And so sine C equals?
H over A.
Yes. Make height the subject.
A equals sine C over H. Is that right?
Let's say times both sides by A. So A sine C equals H. Just bring A to the other side.
Oh, multiplied.
And rewrite area. Sub that in there for H.
Wait, what do you mean sub it in? Like H as in, so it would be area equals a half base times A sine C.
Yep. A half
Okay.
B A sine C, or if you put it alphabetically, a half AB sine C.
Yeah.
What that boils down to in the real world is a half times side times any other side times sine angle between the two sides you picked.
Yeah.
So we just proved it. If you know the height, then the area is a half times base times height. If you don't know the height, you can do a half AB sine C.
Yeah.
Okay, let's give it a go.
Okay. So would you sub in half 4.2 times 6.9 times sine 75 degrees? Is that right?
Yep. What do you get?
Okay, 6. But while we're not, does it matter about the length, like the base? It doesn't matter because when you split the triangle into two triangles, does the base not matter in like lengthwise?
Excuse me. Like we although we split this triangle, so we would have a hypotenuse to get like sine C. The base was the other side, so we did use the whole base.
Okay.
And so it is like side angle between.
But do you not need to split like the base into two parts? Is that not how it works?
No,
Or do you not need to do that? Okay.
that was just to prove it.
Okay. I got 13.99 degrees.
Let's say 14.0. It's an area, and so centimeter squared.
Yeah. Yep.
There we go. 14.0. Okay. Right. How about this one?
Okay. Okay. So, would you need to make the equation height equals a half times a times b times sine c backwards, so you work out the height?
In theory. In practice, just sub in everything you've got.
Okay. So it'd be a half times 6 times b times sine c.
Yeah. A half times. Say it again, sorry.
A half times 6 times b times sine c, because you don't know. Wait, can you use both 6 and 5?
Yep.
Okay, so it'd be 6 times 5 times sine c.
Yep. There's something else you know that you haven't subbed in?
The area is 12 centimeters squared.
Yep.
Okay. Equal half times 5 times c. And then can we simplify?
If you like.
Okay. Times 6 times. So 12 equals 15 sine c.
Mm-hmm.
And then can you divide by 15 on both sides, or would that not work?
That'll work.
Okay. 12 divided by... So 12 divided by 15 is 0.8 equals sine c.
Okay.
So now we know the angle in the bottom right of the triangle, which is c.
We know sine c.
So, so can you do the inverse of sine c and then do it? Will it work?
Yep.
Okay. So it'd be sine to the minus 1, 0.8.
Mm-hmm.
Which gives you 53.13 degrees.
Say 53.1, 3 sig fig. And if we go all the way back to when you first subbed in the 3 values you know and the 1 value you want. 12 equals a half times 5 times 6 times sine x. Shift solve. Roll the dice. 53.1. But maybe they'll throw us a slant ball and we'll have to rearrange something, and they won't let us use the calculator.
Yeah.
Oh, they snaked us. What's this now? Hang on. Find the value of x. A, B, C. What is this? What is 180 minus this answer?
Which 53?
Yeah.
Minus answer 126.86 or 127 degrees.
So what's this snaking about? There are 2 values of x, 53 and that, but here you know that B is the largest angle. Why would you snake me that hard? So because this AC is the longest side. I don't know. How am I supposed to know these things? All right. Hang on a second. Let me look at these questions. 5. Okay, yeah. Right. Other than their little games that they're playing with me. Find the length of B to C. That's easy peasy. Calculate the area of triangle A, B, C. Yeah, we better do it. All right. Question 8.
Okay. So would you work out what C is first? The angle C is. Do you need to work it out?
Yep.
So you do 75 add 52, which gives you 127. Then 180 minus answer, which is 53 degrees.
Okay.
And then you do area equals a half times 16.4 times B times sine 53.
Right. Which side is B in this triangle?
Does it matter which side B is?
Well, depends on the angle you pick.
Okay.
So you picked 53.
Yeah.
So what would be the other side then?
What opposite C? AB?
For the area formula. So a half times 16.4 times some side times sine 53.
Yep.
We've got 2 sides, AB and BC. Which one?
Is it BC?
Yes, because those are the 2 sides that make the angle 53.
Yeah.
That's it. That's all we needed. Part A says find the length of BC, and then you would use that length to find the area. That was the important thing I wanted to see. If you would choose this side over here matched with this angle instead of some other one.
Yeah.
Okay. Yeah. Let me see this thing. No, it's fine. Let's see. Find an expression for A and then the maximum. Same stuff. Man, are they really pushing this? Calculate the value of x. Calculate the value of x is what I thought we should be doing. X satisfies this equation. I think it'll be alright. Is there one? So this looks like a harder type of question because it's got. Oh, they're telling me though. I'm getting the message. Given that is that. Alright, we'll do this one.
Okay. So would you write it out as 43 equals a half times 3x times 2x plus 1 times 3 over 8?
Half times 3x times 2x plus 1 in a bracket times
3 over 8.
3 over 8, yeah.
Yeah.
Because sinus that.
Okay. So could you do 2x half times 3 over 8 first, or would that not work?
Hold on a sec. What was the quick way that I did this one?
You just could put it into the calculator.
Yep.
Okay. 43 equals a half times 3x times brackets 2 plus 1 times 3 over 8. I got x is 5.93 or 94.
5.94 to 3 sig fig.
Yeah.
35.9. Why is that? Did we do something wrong? You got same as me, did you?
Yeah, I got 5.94.
Let me see. So this is question 6. That is 6. Yeah. All right. Triangle ABC. BAC. The sine of BAC. So that's the angle between.
Yeah.
Yeah. A half AB sine C. 43 is equal to half times 3x times 2x plus 1. I know what's going on. It's a quadratic, that's why.
Oh.
So if we did it the long way, we'd get 2 answers. Let me try to snake this. Shift solve 999, a much bigger one. Oh, they're making me work. Shouldn't be. No, it should be. Alright, but we have to do it then. All right. A half times 3 times 3 over 8.
Okay. Times 3 times 3 over 8. 0.5625 or 9 over 16.
All right. So 9 over 16 x times 2x plus 1.
Okay. Okay. Times 2. So it'd be 9 over 8x squared. I think.
Yep.
Plus 9 over 16.
Yep.
X.
Yep.
Would there be x at the end? Yeah. And then you can solve that as a quadratic.
Yep.
I got x1 is minus a half, and x2 is 0.
Nope. I got x1 is the answer that we got. How do you solve quadratics?
I put 9 over 8 into the calculator and then into the polynomials, and it came out as 1.125x squared plus 0.5625x plus 0. Oh, minus 43. I
Yeah.
didn't put in the end.
Have to
You had
make
to minus 43 on both sides.
Yeah.
Yeah.
Sorry, I thought my. Yeah.
Yeah, I got 5.94.
Okay, that's x1.
And yeah, and x2 is minus 6.45. 44, sorry.
So we're getting wrong answer, man. Getting wrong answer. Let's see. What? Calculate the value of x. X is a length. X is a length. They're saying it's an area. It's a misprint or something. I'll have to email them. Fix your book. No, we were right the first time. We were right the first time.
Yeah.
Okay, but actually, it was pretty important. I missed that it would make a quadratic, so there would be 2 solutions.
Yeah.
All right. Okay, I think we're good there. All right, let me just see one thing. All right, they really emphasize this thing. So, hang on. All right, let's do this one.
Okay.
Let's see. How would you do? No. They're really emphasizing. Let me see. Yeah. No. Crazy talk. Yeah, this looks all right. Yeah. All right, let's do this.
Okay. So it wants it shown as a quadratic, right? But with a quarter on the outside.
Sure, but area.
Okay. Would the sine rule work for this? I don't think it would it?
Area.
Oh yeah. Area equals. Okay, so A equals half times x plus 2, 5 minus x times sine 30.
Mm-hmm.
Okay. And then could you multiply the brackets first together?
Yep.
Okay. So the brackets would give you 5x minus x squared.
Mm-hmm.
Plus 10. And then minus 2x. Which simplifies down to minus x squared plus 3x plus 10.
Yeah. And I'll write it the way they did. 10
Brackets.
plus 3x minus x squared.
Yeah. And then you have a half and sine 30. Can you multiply them together?
Yep.
Which gives you a quarter. So it would be A equals a quarter brackets 10 plus 3x minus x squared close brackets.
Yep. Okay. Part B says complete the square. How do we do that?
Okay. So do we need to multiply a quarter by everything in the bracket first?
Nope. Do you remember how to complete the square?
A bit, not a lot, not a lot.
I'm gonna make my life easy. I'm gonna factorize out minus 1. So minus a quarter, and then change all the signs. Okay. So let's say this. We need to put it into a square bracket.
Okay.
So what will that be?
X minus 3.
It would be 3 over 2.
Okay.
Half of 3. Squared. And what goes outside?
Half of 3. 3 over 2.
So it'd be minus 3 over 2 squared.
And then would you work that out?
And you've also got minus 10.
So you simplify minus 10 and minus 3 over 2 squared first.
Yeah.
Okay. Which gives you minus 49 over 4.
Minus 49 over 4. And that whole thing was multiplied by minus a quarter.
Okay.
And so expand the square brackets with minus a quarter.
Is it you multiply x and minus 49 over 4 by a quarter, minus quarter?
Yep. So multiply the bracket, multiply the 49 over 4.
Okay. So would it be minus a quarter x?
Because of BIDMAS, you would have to square out the bracket before you can multiply by minus a quarter. And so you can just leave the minus a quarter at the front of the bracket, like that.
Okay, the last number becomes 49 over 16.
Yeah. Plus or minus?
But it still stays minus.
Minus times minus.
Oh, plus.
And so we want the maximum value of this triangle. Any idea what that would be?
No.
What is the minimum value of a square number? Anything square?
0.
Yeah. And so the maximum value, because it's negative, would be when this square bracket is 0. And so when this square bracket is 0, what remains?
Minus a quarter plus 49 over 16.
0 times minus a quarter?
0.
Yep.
So it'd be 49 over 16.
Yeah, 49 over 16. Let's see. 49 over 16, they wrote it as 3 and 1/16.
Yeah.
No, this is crap. Look at this. You could use differentiation to find the maximum. You literally said use the method of completing the square because I'm a snake man. Let's see. This is the previous one. What would this be? So minus 0.25. That would be 3 over 4. And that would be 10 over 4. Yep. The maximum value for x is 1.5 because that gives you the bracket being 0. And there we go. Maximum y, 49 over 16. So if you're using any method, you just stick it in the calculator. You told me completing the square, bookie. See, look. Where is it? This one here. By completing the square, find the maximum. Yeah. This one wanted me to find the x part, not the y. Okay.
Yeah.
Okay, grand. We did it. I'm not doing more. If they don't know what they're doing, then I'm leaving it. Okay, so calculate the area of this floor space.
Okay.
No. You're good. Okay, areas of triangles.
Tick. Find it pretty easy.
Grand. Okay, solving triangle problems. Let's take a look.
Mm-hmm.
70 meters apart. Okay. Four mobile volters.
So could you split it into a triangle, 2 triangles?
Which way?
From B to D.
Alright.
But since you've split it, you don't know what that angle D is now.
Yeah, I believe so.
Okay. Area equals half times A times B times C. So could you do area equals a half times 75 times 80 times sine 55?
Yep.
Okay. which gives you, oh, that's a big number, so we do the inverse.
No. No. What inverse are you doing?
It gave me the answer 2000. Wait, oh, wait, no, that's right, isn't it?
And it's not even big enough. So what did you find the area of?
One side
Yep.
of the field. So half times 75 times 80 sine 2,457.45.
All right. And so that's which area?
The area on the right of the red line.
Okay, so we want total area.
We just double it.
Yep.
Which gives you 4,914.9012266.
I'm gonna say 4,910. 3 sig fig.
Okay.
What is this? Meters squared. So that's part C. What is part A?
Squared. So A is the minimum distance from D, how would you figure out what AB is, because all the sides are uneven? At least, okay. So would AD be 70?
Yep. That one's 70, and then you have to find the angle BAD.
Okay. Okay.
Let's see.
So would you use the equation area equals a half times A times B times sine C?
How would you use that?
So it'd be 4,910 equals.
But we don't have two unknowns, I believe.
Okay. But we don't have the angles B or D when it's split into a triangle. Two triangles.
I'm looking this up because I can think of a very long way of doing it. Just don't want to. What was this? So it was just very long. You have to use cosine rule, sine rule, sine rule. Yeah, it's just very long. So you see these two. You could use the cosine rule to get the length of the red side.
Yeah.
Then you could use another rule to get another length, then another rule to get an angle, and so on.
Yeah.
All right. That's the example question. I'm hoping that that's more of a teaching question. So 4940. All right. So let's see. So this looks like there's less going on. You see, the reason why is because this is solving triangle problems, but that's not a triangle. They split it into two. But let me just see this one. Oh, is this a duplicate? Oh, is this a duplicate? So that should be in previous section. Am I wrong about that? I think we did this question. I think we did.
Oh yeah, we did. The top angle's 53, I think.
Calculate the area. So that's question 4. The rest look okay, I think. Hang on. Find the length of BC. Yeah, we did. We looked at that one. This one. Oops. I cut out the triangle. Did I? I don't know. No, I didn't. We did this one. No, or did we? Or are they just the same? Are they just the same? Let's see. So we're given two sides and an angle. We're told the area. Oh no, this looks different. All right, let's give this a go.
Okay. So I did 48 equals a half times 15 times 8 times sine theta.
Mm-hmm.
And then I simplified, which gave me 48 equals sine 60. 48 60 sine theta.
All right.
60 sine theta. And then I divided by 60 on both sides, which gave me 0.8 equals sine theta.
Mm-hmm.
And then I did the inverse of sine, which is sine to the minus 1, 0.8, which gave me 53.1301 degrees.
Okay. 53.1, so that's 3 sig fig. Maybe we'll need to... What was that, 5 sig fig, sorry? 53.13...
53.1301.
130, okay. We can see 53.13. Let's see. So that's sine. Find the two possible values of cosine theta. Any idea how we go about that?
Okay. Do we use the cosine rule then?
No. What is cos theta?
So would you just do... Wait. Would you put cos to the minus 1, 0.8?
Yep.
Which gives you 36.86.
Hold on.
Or 87.
No. Cos theta.
So would it just be cos 0.8? Or is theta a different number than to what we got for sine?
You tell me. What is theta?
Theta is the angle ABC.
Yep. What's the size of that angle?
53.13.
Yep.
So would it be cos 53.13?
Yep.
Which gives you 0.6.
Go on. Is it exactly 0.6?
And then 4 zeros.
Yeah. If you did cos answer, I think you would get exactly 0.6. How do you get second answer for cos?
Would you do cos and then minus the minus 53.13?
What minus 53.13?
180.
That's sine. So sine theta is equal to sine 180 minus theta. Cos theta is equal to cos what minus theta? It's not 180.
Don't know.
It's 360.
Okay. So would you write out as cos brackets 360?
No.
No.
Oh, sorry. Yeah, you would. Cos 360 minus, go on.
Okay. Cos 360 minus 53.13.
Yeah.
Which gives you 0.6.
Why would they? So in this case, I think what they're referring to is I'm not sure. Did we do solving trig equations? Did we do sine squared theta plus cos squared theta equals 1?
No.
So
I don't think so, no.
I think that should be plus or minus 0.6. So I think they're relying on, when you know more, it'll be more obvious. They're relying on knowing that the graph is symmetrical or something.
Yeah.
Okay, and B.
Okay. Could use the cosine rule for this.
Yep, well done.
C squared equals A squared plus B squared minus 2A B cos C.
Well done.
Okay. So we don't know what. So C squared is theta squared. Wait, no, it isn't. C squared is unknown, so it'd just be C squared.
Yeah,
equals
AC squared, right? If you
15
want.
squared. Yeah. 15 squared plus 8 squared minus 2 brackets 15 close brackets 8 close brackets cos theta.
What is theta? Or what is cos theta?
53. Oh, you could just put 0.6.
Yep.
Brackets 0.6. And then you can work that out. 15 squared add 8 squared minus 2 brackets 15. Which gives you 145. C squared equals 145. And E squared at 145, which gives you 12.041, or just 12.
Centimeters. I have a crazy idea though. Remember two possible values, plus or minus 0.6?
Yeah.
Now try it with minus 0.6.
As in like cos 360 minus, wait.
So remember you did like 15 squared, 8 squared, 2,
Okay.
15, 18. So this time times minus 0.6 at the end.
Okay, 8 squared minus 2 minus 15.
You can just press up, but anyway.
Times, was it minus 0.6?
Yeah.
Minus 0.6, which gives you 433.
And so square root that one.
Which gives you 20.80, or just 20.8.
20.8, and so we wanted the longest side of the track. Sorry, given that AC is the longest side, what is the length of AC?
20.8. Is that the longest?
Yeah, root 433. and it was plus or minus 0.6.
Yeah.
Yeah, and so that's just something to look out for. It's because cause is symmetrical, it's plus or minus, and so we had to try both, and that was longer. And so that stuff, what do you give yourself?
Probably a tick. I found it pretty easy.
Yeah, great. And so continues next time.
Yeah.
Any questions for me in general?
No.
All right. Well done, Adam. You're doing great. And yeah, have a nice weekend.
You too.
All right. Take care. Goodbye.
You too. Bye.
Bye.